Look closely at your enterprise AI pipelines, and you'll see the cracks. The standard approach to retrieving data, what we call traditional RAG, is shattering under the weight of real-world complexity. We are right in the middle of the great RAG collapse of 2025. To understand why it's failing, look at how these systems were built. Early language models had tiny memory buffers. They physically couldn't hold a massive book-length document in active memory. So engineers built the retrieve-then-read bottleneck. That bottleneck forced a clumsy band-aid. We took massive, cohesive documents and sliced them into tiny fragments. We stored those fragments in vector databases, storage systems designed to hold mathematical representations of data, and then tried to fish them out using basic keyword fetches. This architecture did exactly what it was designed to do. It created a highly efficient machine for fetching specific words.
However, it lacked the structure to understand what those words actually mean. The root cause of this failure is a condition called semantic loss. This deterioration starts the exact second a continuous, well-argued document is chopped up into disconnected chunks. Think of a complex legal contract. Paragraph 4 only makes sense because of a definition in paragraph 1. When you slice those paragraphs apart, the data chunks lose their semantic soul. The surrounding context that gives the information its actual meaning is torn away. The problem compounds when the system tries to answer a prompt. It uses a technique called top-K similarity search, which grabs the topmost mathematically similar pieces of text. It rips these isolated fragments out of their original sequence and forcefully stacks them together. This flat vector approach only looks at the surface level. It remains blind to the complex, nonlinear relationships hiding deep within your data structure. Without global awareness of the entire document, the system is just guessing. You can feed an AI the exact right disconnected pieces of information, and because it lacks the connective tissue between them, it will confidently guide you straight into a dead end. The physical constraint that caused this problem no longer exists. We now have models with 2 million plus token context windows. A token is a basic unit of data, like a word or part of a word, that an AI processes. 2 million of them means the old bottlenecks are gone. The practical impact here is massive. Instead of searching a cold storage database for a single function, an AI can now hold entire codebases and vast reference libraries simultaneously in its active working memory. But having a massive disk doesn't make you organized. If you blindly dump gigabytes of raw data into a single window, you overwhelm the model. You generate paralyzing informational noise. Expanding the capacity of the system does nothing if the AI lacks a structured, active method to navigate the dense information you just handed it. The solution requires moving away from passive retrieval scripts. We have to architect active agentic memory models, systems that actively reason through their environment. It starts with the first software pillar, internal knowledge graphs. Instead of flat lists of vectors, these models build dynamic networks, actively mapping how distant data points conceptually connect across a massive document. Next are memory controllers. These utilize a mechanism called sparse attention. Sparse attention is an efficiency technique where the AI only focuses on a small, relevant fraction of the data at any given time, allowing it to prioritize high-signal facts and actively prune out the noise. Finally, we apply iterative reasoning loops. Rather than spitting out the first answer it finds, the model continuously loops back, actively querying its own internal memory to verify its facts before generating a final response. These 3 pillars integrate to turn the AI into an active participant in its own cognition. Maintaining this kind of long context memory does require a trade-off. Running continuous reasoning loops and massive context windows inherently consumes significantly more computational tokens. But you have to weigh that increased compute cost against the demands of the real world. Modern business applications do not have room for error. They require high accuracy, enterprise-grade reliability. When a legacy RAG system loses context and hallucinates a financial figure or a legal clause, the downstream damage is massive. Dynamic graph reasoning replaces those unpredictable errors with a stable, verifiable process. The financial risk of a company acting on a confidently incorrect AI hallucination outweighs the extra computational cost of running an agentic system. Static data retrieval has hit a functional ceiling for competitive enterprises. The next evolution of our digital infrastructure will be reliant on autonomous assistants equipped with personalized, persistent memory that actually comprehends the tasks they are given. To navigate this shift, engineering leaders should begin tearing down their legacy pipelines and move toward integrated long-context frameworks. Architecting for a long-context agentic future provides the structural framework required for models to reason through their data with high fidelity.